Today we will continue our decimal lessons with subtracting decimals. Today's lesson we will subtract decimals using place value strategies. We're going to use the place value chart and relate those strategies to a written method. We're going to use what's called the standard algorithm. If you will, take a moment, pause the video, write your learning target in your journal. Today, I will subtract decimals using place value strategies and relate those strategies to a written method. Here's a sample word problem to get you started, very similar to something you may see on a test. At the 2012 London Olympics, Michael Phelps won the gold medal in the men's 100-meter butterfly. He swam the first 50 meters in 26 and 96 seconds. The second 50 meters took him 25 and 39 seconds. What was his total time? Show your work and explain your thinking in the space provided. Write your answer in the grid. Well, when we look for our key values, we're going to have 26 and 96 hundredths, 25 and 39 hundredths, and it's asking us the question, looking always for the question mark, what was his total time? We have to show our work and explain our thinking. We're writing our answer at the end in the grid. So we're going to start by showing our work, adding 25 and 39 hundredths to 26 and 96 hundredths, starting by lining up our decimals, adding in the hundredths place. 9 plus 6 is 15. 9 plus 3 is 12. Plus 1 is 13. Carry over to the ones position. 6 and 6 is 12. Adding 2 plus 2 plus 1 is 52 and 35 hundredths seconds. We would write that on our chart. 35, 52. You bubble in whichever numbers correspond with your correct answer. And how can we explain this? How can we explain our answer? We would tell our reader that we use the word total means to add. So we're going to find the total. Total means to add the times he swam the 50 meters. 100 meters. Well, 50 meters. 50 meters and then 100 meters. So he swam 50 and then 50. So his total time for the 100 meter was 52 and 35 seconds. So using the place value chart, something we need to do quite often is compare values and subtract or add values in the same place value position. So this is 5/10 and 3/10 written in word form for us. We'd fill out our place value chart and then we're going to try to find the difference. Finding the difference means to subtract using the place value chart. We can explain our reasoning about solving the expression at the end. So we're going to subtract 5/10 minus 3/10. And when we take those two values and line up the decimals, 5 minus 3, we're going to get 2/10 as our correct answer. So 5/10 minus 3/10 is 2/10. Again, using the place value chart to write out our two numbers, using subtraction to find the difference. We're thinking vertically using the algorithm. So we're going to start off by placing these values in a place value chart. So 7 ones and 5 thousandths. No tenths, no hundredths, 5 thousandths. You can try to add the next one, 2 ones and 3 thousandths, and see where they would land on the place value chart. 2 ones and 3 thousandths. We start in the ones place with our 2 ones. Again, nothing in the tenths place, nothing in the hundredths place. 2 ones and 3 thousandths. And we can begin our subtraction using the algorithm called the standard algorithm, thinking vertically. So we're going to start with our first value. 5 minus 3 is 2. 0 minus 0 in the hundredths place. 0 minus 0 in the tenths place. And 7 minus 2 in the ones place. Our correct answer, we wrote it out in word form, would be 5. Whoops. Doesn't want to write We write that out in word form in your journal. 5 and 2 thousandths. Next question is, what did you have to think about as you wrote the problem vertically? Where did you have to align your decimal and your place value? Here's a similar problem, but instead of having word form and word form, we have standard form minus word form. So we're going to do the same thing. We're going to put on a place value chart 9 and 2/10 minus 6 and 4/10. 6 ones, 4/10. Subtracting that in your journal, you can't take 4 from 2. I'm going to go to the ones place, take 10 ones, add it to the tenths place. 12 minus 4, you get 8, and 6 taken from 8 is 2. 2 and 8/10. How is this problem different from the problem we just solved using the two-word form? How did you solve this problem using what you learned from the last? See if you can begin solving this problem in your journal. Both in standard form, 831 thousandths minus 292 thousandths. You can use this place value chart in your journal. You can write it using standard algorithm on the lines. Start to solve 831 thousandths minus 292 thousandths. And we'll go over it together. Starting with the value 831 thousandths minus 292 thousandths. Lining up our decimals always. We're going to add 10 to the thousandths place that we took from the hundredths place. And to add another 10 from the tenths place. So 11 minus 2, we'll have 8 thousandths. 12 minus 9, we'll have 3 thousandths. 7 minus 2 will have 300. 7 minus 2 will have 5/10. Our correct answer is going to be 538 thousandths. If we want to check our work, we can always add our difference and see if we end up with 831 thousandths. 8 plus 2 is 11. 9 plus 4 is 13. 6, 7, 8. I get 831 thousandths, and that's the one number we started with. Very good. Here's a slightly more challenging problem. We have 6 ones, or 6 minus 48 hundredths. How would you write this problem out on a place value chart? How would you begin to solve 6 and 48 hundredths? What do you notice about this problem? Well, the first thing I notice is that there's no decimal place values indicated behind the 6. So what would I do? Where would I put the 6 on the place value chart? How would I begin? There's actually zeros and continues on indefinitely. We only need 2 for this problem. So you would just add 6 as if you were writing $6.00. And you would subtract 48 hundredths, or if we want to equate that to money, 48 cents. We're subtracting over zeros. So our first value is going to be the 10 hundredths we don't have. This tenths place has 0 to borrow from, so we're going to put a 9. And now we take from the ones. So the ones place gave the 9 to the tenths and gave value to the hundredths as well. So now we can begin our subtraction. 10 minus 8 is 2. 9 minus 4, 5. And 5 minus 0 is 5. So $5.52, or 5 and 52 hundredths. So how can we think about the 6 wholes in the same units as 48 hundredths? We could do it as 600 hundredths. We moved it over by composing 6 wholes into 600 hundredths. Have we changed this value? Absolutely not. 6 wholes and 600 hundredths are the same in unit form. One more for you to solve on your own. 4 and 83 hundredths minus 1 and 83 thousandths minus 1 and 29 hundredths. Pay careful attention to the place values I just mentioned, 4 and 83 thousandths, minus 1 and 29 hundredths. What do you notice about the thousandths place that's used there? What's missing? To find the difference, you can use your place value chart, record your thinking vertically in your math journal using the standard algorithm. I'm going to start by writing our 4 and 83 thousandths. Then I'll write our 1 and 29 hundredths. How would I begin to solve this problem? What can I add to the thousandths place to assist me in subtracting in this value on the end? So let's start by adding a 0 in the thousandths place. 29 hundredths is the same as 290 thousandths. I can begin my subtraction after I add a 0. So 3 minus 0 is 3 thousandths. Can't take the 9 from the 8, so I'll have 18 hundredths. Nothing in the tenths place. I'll go to the ones place. So 18 minus 9 is 9 hundredths. 9 minus 2, 7 tenths. Decimal. Bring that down. 3 minus 1 is 2 ones. So 2 and 793 thousandths. See if you can write that in word form. See if you can write that in expanded form in your journal for practice. All right, students, you've done a great job today with our learning target. Our objective was subtract decimals using place value strategies. We've subtracted in the tenths place, the hundredths place, and the thousandths place. We had various examples of what to do if those place values were missing for us, and how to solve questions using standard form, expanded form, word form, and even word problems. Relate those strategies to the written method. Remember, our written method is called the standard algorithm. You may also see it written as just algorithm on one of your tests. So practice on your test paper today, your practice your problem set, continue on your exit ticket, and show how you use your subtraction skills using decimal place values.